When you press send on your phone or turn on your Wi-Fi router, something invisible leaves an antenna and somehow reaches another one kilometers away.
Most people imagine wireless signals as a clean beam traveling straight through the air like a laser.
But that's not what actually happens. Once an RF signal leaves the antenna, it doesn't follow a single path. Once an RF signal leaves the antenna, it expands into space. Not because energy is lost, but because it spreads out.
As the signal travels farther, it becomes weaker, not because energy disappears, but because the same energy is spread over a larger area.
Imagine shouting in an open field. Close to you, the sound is loud. Far away, it becomes faint. Not because your voice got weaker, but because the sound spread out. Here's the surprising part. Nothing physical is traveling from one antenna to another. No particles, no chunks of energy, just fields changing in space. Those changing fields come in pairs, an electric field and a magnetic field. They don't travel separately. They rise and fall together, shaping how energy moves through space. And here's the key insight. Energy flows where the electric and magnetic fields overlap. Not inside the wire, not carried by electrons, but guided by conductors and transported by fields. In wireless systems, there is no wire to guide anything. The energy doesn't need a path. It propagates through space itself. Electric and magnetic fields detach from the antenna and move outward together as a wave. As the wave travels through space, something important happens. The energy spreads out. The same amount of energy now occupies a larger and larger area. So, even though the wave is still there, its intensity decreases with distance. This is what we call attenuation in free space. Not all radio waves behave the same way. As frequency goes up, wavelength gets shorter, and shorter wavelengths spread less efficiently through space. That's why low-frequency signals travel farther while high-frequency signals fade more quickly. Same physics, different reach. So far, we've talked about free space. But the real world isn't empty. When a radio wave hits walls, buildings, or terrain, part of its energy is absorbed, part is reflected, and part continues forward, just weaker. This interaction with the environment is another source of attenuation. In real environments, a signal rarely takes just one path. It reflects off walls, buildings, and objects, arriving at the receiver from multiple directions. Some paths reinforce each other, others cancel out. This is called multipath, and it's why signal strength can change, even when nothing moves. Even in perfect empty space, signals lose strength, not because the energy disappears, but because it spreads out. As the wavefront expands, the same energy covers a larger and larger area. This is called free space path loss. It's not decay, it's geometry.
So let's zoom out and look at the big picture. Wireless energy doesn't travel as a substance, it propagates as changing electric and magnetic fields, spreading through space, interacting with the environment, and gradually weakening as it expands. Distance, frequency, obstacles, and reflections all shape what finally reaches a receiver. Once you see wireless this way, radio stops being mysterious and starts becoming intuitive.
If this video changed how you think about wireless, that's exactly what this channel is about. Breaking down RF, radio, and wireless systems until the invisible becomes clear. Subscribe to RF 101 Explained. New videos explore how signals propagate, how antennas shape coverage, and how real RF systems behave in the real world. If you're curious about wireless, you're in the right place.